Okay? So in H2, it says we are working with reflections now and congruence. And so as you are looking at these, a reflection is a transformation that's a mirror image. We have a line of reflection. So what I'd like you to do with these three logos that you see, draw your lines of reflection. Draw your lines of reflection. Okay? They're all car logos. Now the first one actually has how many lines of reflection? Draw the lines of reflection. The first one actually has 3, right? Whereas the other 2 only have 1. So if we are looking at those, this first one actually has the 3 going from each kind of point going across, right? Each one of these is going to be our line of reflection as you're looking at it. Whereas this logo is just going to have that vertical. Same with the Volkswagen, right? It's going to be vertical. Okay? All right. As you look down in your notes, do you just need a pencil or here's where? Okay. So as you look down in your notes, it says a reflection can be found all over the place. Here's a mountain that reflects over a lake. Look at the snowy part and how it's reflected. So a lot of times you will see this, especially on a really calm, clear day if you're looking at the lake. So here it says every point in the blank is the blank from the line of symmetry. So what we should be looking at, or from that shoreline, is the same distance. So when we do a reflection over that reflection line, we're going to have the same distance. And the other thing that we're going to be talking about is that reflection has the same size. Okay? So we're looking at it being the same, as we look at that, the same distance and the same size as we are looking at that one. And as we look at this one, and today we are going to have just a really short homework quiz as we look at this. What are some other things that if you were going to notice about this picture? I just want you to silently write down a couple more things that you are noticing about this. What else do you notice when we have a reflection? And if I think of walking up this mountain, right, I'm going in which ways you think of going around the clock if I go up and down. So this is clockwise, right? If I'm going this way around, I'd kind of go around this picture. So that's one of my hints that we're going to talk about. Something else you might notice. So I want you to think about what are something else that you might notice. We said it's the same distance from this line of symmetry, what we talked about here. It's the exact same size. I want you to write down one more thing that you think you notice about this picture. And it doesn't have to be mathematical, just something else you notice. Right. Start writing. Write something. You should fill those 2 in, yes. Just write one thing. All right, Jaden, tell us one thing.
So I'm looking in a mirror.
Looks like looking in a mirror. It's like looking in a mirror. Wait.
It's the same object. It's just like on the opposite, like you know what I'm trying to say, like opposite side. Like it's gonna like rotated.
It flips it.
It's not.
So it's not rotated, but it like flips. And if you were talking about it, it's the opposite direction. So by what we mean opposite direction, and this is a key word in mathematics that we use the word orientation. Okay? Orientation means that if I was going up this mountain and around, that's like going around a clock, right? So the original, so by this word original, I want you to put clockwise orientation. Just from where we started, if we were walking up this hill, we would be going clockwise. Now, if I started on the same point down here, which way am I? I gotta get a different color pen. If I was starting down here at that same point, right, and I want to go up and around, which way am I going now? I'm going counterclockwise. So the reflection is counterclockwise. And the cool thing about reflections of all the transformations we're going to do, that's the only one that switches the orientation. All the rest of them keep it the same. Did you have a question or comment? Okay. All right. So, as you look at the top of the next page, you see this figure. And I do not need yours in your notes to be precise as we look at this. But it says if we were going to reflect it over the line, and some people said, oh, do you have those mirror boards? And we don't. So it says reflecting this figure over this is called the transformation. You might have used those in elementary schools. They're kind of colored. You set it right on the line, and then you could see the reflection on the other side. But what do I know about point B from this line? If I'm going to do point B prime, it needs to be the exact same distance, right? So this would be my B prime. And if I would measure where A is, so you can just approximate it, I want you to put A prime. And the same with E. Now what I know about E is it's going to be straight down, right? And again, yours doesn't have to be perfect, but E prime would be here. And we're always going to use that symbol, that prime, that little tick mark for our prime. And here would be my C prime. Okay?
Looks like Minnesota.
It does kind of look like
With the
Minnesota.
only edges.
Okay? So, it doesn't have to be perfect. It says when we put the new ones, we call this mark prime. We don't want to say B1, it's called B prime. Sometimes we'll have B double prime, C double prime. The two figures are congruent. Mathematically, this is the symbol that you're going to see for congruent. It's an equal sign with a squiggle over the top. So, approximately equal is this symbol. This is approximately equal, okay? It's not that. This is approximately equal, right? Congruent is when they have the same size and the same shape, okay? This is the symbol that we use mathematical for congruent. So it says if you were to cut out these two figures, we could move them around and show that they're the exact same. Could we show that they're the exact same size and shape? If we drew ours perfectly, yes. It says, is the reflection always going to be congruent to the original figure? Yes. So it's not going to change shape or size with a reflection, okay? So later this unit we'll take a quiz on this. We're going to take a small one today, just on a couple of things, but it's really simple on what you had to do yesterday. So this one says, transformation, drawing window in many computer geometry programs, and this is kind of an older one, and it shows that this is the grid for how they drew this, okay? So, it says when you transform the design, the coordinates of its points change. And specifically, we're talking about rules to x, y. So when we do our rules, as we look at this, we're always going to say, what happens to x, y? This is always going to be our original figure. Let me make sure I can spell that for you. Original. And then this is going to be what's called our image. And then we're always going to kind of use the same kind of notation. We're going to use the parentheses. Why parentheses? Because it's an ordered pair. If you don't put parentheses around it and you just put the numbers and you put the 0, -2 without the parentheses, it is not telling me an ordered pair. So I want you to see how they came up with this for the flag. Okay. 0, -2, that's where the flag started. Goes all the way up to the top. Then it goes from 0, 3 to this 1, 2. So 0, 3 to 1, 2, that's this line of the flag, right? 1, 2 to 0, 1, that's this line of the flag. Just so you're kind of figuring out where they're using this, okay? So now I want you to take a look on the top of the next page. We don't have too much more, it goes pretty quick. We're going to look at this flag, And it says we want to reflect it over the y-axis. Okay? Now, before I even plot it, is this point 0, 0 going to change at all? No. Right down here, this point's going to stay the same. If I'm going to reflect this over the y, this point over here was originally at 5, 5. So this one stayed at 0, 0, right? This one is going to be now at, is it at positive 5 still, if it's going to be over here? It is negative 5, 5. Okay? So I now have this part of my flag, right? The flag went down to the point 5, 3. So I have to put this one, these two notice are the same, so this is the negative 5, 5. Where does it have to go down to? To negative 3? Way down here?
No, negative 5.
Negative 5, 3. And then please tell me the last two. And notice that these two are always going to be the same. Okay? So do that last one and then check with your shoulder partner. And if your desk is not next to your shoulder partners, please push them together because they should be back so that your desks are right next to each other. Okay? Then check quietly, do it. Check just with your shoulder partner. So you're going to move over that one. Okay? Whitney, did you guys come up with something? Have you talked yet? Did you check each other's? Okay.
0, 0, negative 5, 5,
A little quieter. Whitney, what'd you guys come up with?
negative 3, and then like comma.
Negative 3, comma 3. Everyone get that for the last one?
Yeah.
So it says, what do you notice from all of these up here to all of these down here? What changed when you reflect over the y-axis, Kylie? The x is negative. So the coordinates are in the same order I want you to put down. Coordinates in the same order, right? But it is the opposite of x. How do we write that, how we're going to put the rule? X comma y changes to negative x, y. And this is the rule for reflecting over which axis? Over y.
So just like y is negative 1.
You said you could say that it's the same as multiplying it by negative 1. So let's do, we did the y-axis, right? Gotta scroll down a little further. Let's see. Okay, so you're looking at this picture. So if you look at this one, we just did this reflecting over the y-axis, right? And we found that xy changed to negative xy. Does it make sense if we were to reflect it over the x-axis that the points are going to become, like if it was 2, negative 3, it's now going to change to x, negative y. So what Sanjay was saying is that it's the same if I'm reflecting over, the order stays the same, but we're multiplying like by a negative 1. I like to think of it better as even saying instead of multiplying by negative 1 is that this is the opposite of x. Because if the original x is a negative number, right? So let's put the point negative 4, 4. If I look at negative 4, 4, and I want to reflect that over the y-axis, the new one is going to be 4 and 4, right? So, right, y stays the same when you reflect over the y-axis, the x changes. When you reflect over the x-axis, that's like going down, right? the y changes to the opposite and x stays the same, okay? So, as you continue, there wasn't really anything to write down, that's just kind of in your notes. We now want to actually do this picture. So, we want to reflect it over the y-axis. And I think the easiest way to do this reflection over the y-axis is to draw it first, even without listing my points. Simply draw it first, right? What do I mean by draw it? I'm going over the y-axis. I just want to make sure I'm going over the y-axis, right? I'll have some people do the x instead of y. They'll get their final picture to end up down here. That'd be wrong, right? This is going to be my C prime, right? How far between C and B? 2. Oh, nice. I'm going to go over here and go 2 units, B prime. Between C and D, I notice it's 3 down. D prime. A is over here. It is 4 away. This has to be 4 away. Okay? I don't always have to list those points. Yeah, some of you went down below instead. Could I list the points if I asked? Could you list the points if I asked you to? Please do that right back here. Tell me what your new points are. And we'll just do it for A and B. I want you to list A, and then I want you to put A prime. I want you to tell me where B is, and then I want you to tell me where B prime is. Okay? So if I'm going to look at A, where is your original A, Emma? -4, 3. Abby, where's the new A prime?
+4, 3.
Yeah. Zach, the original B prime. Oh, excuse me, the original B.
Oh,
B, not D. -3, 4. And our new B prime, if I was looking, Lucas, would be?
Our new B prime would be
Where is that?
+3, 4.
Okay, so when we reflect over the y-axis, we notice that the y points stay the same, the x's become opposites, right, Whitney?
You want to label these like primes, so which one's prime, which one's
The original one's not going to have a prime by it. Your new one will always have a prime. And then in your homework pretty soon you'll do double prime and triple prime, because I'll have you do 3 different things. That just means this is the new one.
Okay, prime is
Yep, this is the original, the prime. So, I want you to write down and kind of check with your neighbor just really quietly. Do you think these two are congruent? Same size, same shape? And how could we prove it? How could we prove they're the exact same? Say, quietly, talk with your shoulder partner. Okay? Think of ways we could prove it. Anyone or their partner have an idea? Raise your hand, Nick.
Find the area.
We could find the area of each. That would maybe prove they're congruent. Okay? Find the area. Anyone else have any ideas? Yes?
Check the distance.
We could check the distance. I like that. The distance of each segment, right? Or the length maybe we could put. I like that. The length of each segment. Emmy, what else? Or Emily, what else? We could fold it over the line. You could fold along that y-axis, right? Fold on the y-axis. So what else besides the length of each segment being the same, what else would have to be the same for it to be congruent? What other thing do we maybe kind of look at, Elena?
The height.
Well, those heights, there's something else.
The angle.
The angle. So we want to make sure the lengths of each side is the same, and we want to make sure the other key thing is that all the angles are the same measure, are congruent or equal. I'm going to put congruent, or you could put the equal, okay? Meaning, if I was actually going to take my protractor and measure this, and I see, oh, this is a 90-degree angle here. When I draw this one over here, this has to be a 90-degree angle, right? If I would measure this one and it comes out to be like 70 degrees, right? I would want to make sure that this one is 70 degrees. They have to match up. They have to be the same, okay? So same angle and same length. We already saw these were the same length. This was 2. This was 2. This was 3. This one is 3. Could we have figured this one out using the Pythagorean theorem, what the length of that is? Yes, so we could find the, okay? So, all right, this time you're going over the x-axis. You're going to have these two triangles kind of overlapping. So do it over the x-axis. Now, sometimes my hint is people go, oh, which one? I'll even extend this line a little to make sure I do it over this line. So here is H. H was originally located at 3, -1. Just graph it, right? Put it right up here. H prime. 3, +1, right? Do the G. G was up how far from the x-axis? Up 4. Now you need to go down 4. I mean, that's as easy as reflecting over the x and y axis, right? Do the F also. And then like I did next to H, at least next to G, list your ordered pairs. Because then we're going to try and answer those questions. Look at that part on the bottom. Okay? F was up 2 and it's down 2, right? All right, so when we talk about the orientation, it's how it's positioned in the graph. It says FGH is oriented at the center of the grid, long, narrow triangle pointing to the top. So I like to think when I think of this orientation, if we go in alphabetic order, so we'd start with which letter up here? G. What's our? Good, F. F, G, H. So if we go from F to G to H. F to G to H. Is that like going around a clock or counterclockwise? F to G to H. Clockwise. How do I get clockwise? I went from F, right, to G to H. That's like going around the clock, like the numbers on a clock, right? Okay. So now I want to go around the new one, which was called F prime, G prime, H prime. So if I'm looking at this one, right, F prime to G prime to H prime. I'm starting with F and going to G prime and then to H prime. That is counterclockwise. And here's the thing I want you to remember as you do this. The only transformation that is going to change the orientation. How does the orientation change in this reflection? It changes, it switches. That's how it's the easiest way to put it. It went from CW clockwise to counterclockwise, right? CW makes sense for clockwise. Clockwise. Counterclockwise. Okay? So it switches the orientation. We're going to do slides. We're going to do some other things. So as you are taking a look, I know there is one more. And notice this one, what it tells you to do, it tells you to do 2 things. I think instead of doing this, skip it. We are going to go to your homework, and we're going to get started.
That's not homework.
That's not homework.
That's not our
We're Creoles, or I'm offended.
No, that's still not our
I know. Yours doesn't look exactly like this. So I'll put yours up in just a minute. So, as you look at yours, H2, okay? So as you look at your H2, look at that first picture. What are they asking you to do in H2? You have to plot the points, right? When you plot points on H2, keep in mind your X and Y. X always tells you from the origin to go right or left. The Y tells you to go up or down. Okay? So, plot and draw, and it'll say, draw this triangle, ABC. Nick, have you started? Keep going. So, you're going to plot the triangle. That means you need to connect the dots, right? Make it a triangle. Put the letters, A by the point, B by the point, C by the point, right? And I'm going to put the A prime, B prime, C prime with it.
It's already doing that.
Yes, because on the quiz, that's how I'm going to know, because it'll say reflect it and label, okay? So when I'm looking at yours and I see the -1, 7, -1, 7, and I call that A, and I'm reflecting over the x-axis, I should be at -1, -7, right? And I should see A prime. Okay?
I know, but
Number
you have
4 doesn't make any
Okay, can you
sense.
come here, please?
Do you have to do what?
Um,
Which one? Number 4?
Oh, I just thought that was part of number 5. Oh.
I know, you're 4. What happened is that, like,
There was one really dark one up here, but there's 2 light ones down here.
so you got 4. Yeah. That's just because you see the map.
No, negative 0, right?
There is no -0.
0.
So 0 is nice. If it's on one of the axes, when you reflect it, it stays there. When you get into geometry, not next year, but that following year, you do reflections other than over the X and Y axis. You do them other ways. What's that? 0 is a number, yes. Okay?